All right. Good evening. Tonight I'm going to work on a problem called Quadratic Inequalities. All right. And I'm going to do one variable and two variables. All right. So now let's start out with an example. Okay. So I have x squared minus 2x minus 3 is greater than y. Well, now you're seeing a y and an x here, so this must be the two-variable version. And if I had x squared minus 2x minus 3 is greater than 0, you're seeing one variable going on. Well, that would be your one-variable version. All right, so I always tend to set it equal to solve. And what I would do here is set x squared minus 2x, okay, minus 3 equals 0. And I can proceed as the old-fashioned way. And I realize that I can factor this out and solve x, so I can get an x here and an x here equals 0. And I guess I have to have one of them needs to be plus, one needs to be minus, because I have a minus term here. So I'm going to put a plus here and a minus here. And then when you multiply this guy here and this guy here, you get 3. So 3, what are the factors of 3? 3 and 1. I'm looking for whole numbers here. I mean, you could have all kinds of crazy numbers, but this is a simple example, so it's going to give you whole numbers. And now I have the 3 is bigger than the 1, so I'm going to get it's negative, and I'm going to have this positive, and when I add them together, I get a -2. So that works out for the middle. So I have minus 3 and then plus 1. Okay. So this is this is what I have here factored out. Now, what this is saying is x plus 1 equals 0, or x minus 3 equals 0. So I minus 1 from both sides. I get x equals -1. Or in this case, x equals plus 3. So these are what used to be the x-intercepts. These are x-intercepts, okay? And if you look at them on here's 0, 1, 2, 3, 1, 2, 3. Okay, I'm going to put a circle around this guy to start out, because I don't know when I put in the inequality sign, I don't know what's going to really happen over there. Okay, so, and there's that -1. So it's -1 plus 3. Okay. Now, we don't have y stuff going on. We just have x stuff going on in this one I'm solving. I'm solving this one variable version first. Okay, so let's get back to what we had now. We had x plus 1, x minus 3 is greater than 0. Okay, so that's what I have factored out. And so now I'm going to start to probe in and around here and see what's going on. So first thing I'm going to probe is I'm going to let x equal -1. Let's see what's going on over here. When I do so, putting it in here, I get -1 times, plus 1, okay, -1 minus 3. Okay, that has to be greater than 0. Okay, so what do I get here? I get -1, that's 0. So essentially, I get 0 times -4. Well, that's 0. Is 0 greater than 0? No, that's a false statement. So the solution does not live at x equals -1. There's no solution there, okay? So nothing going on there. Let's let x equal +3. Let's check the other thing I came up with here, right? All right, so x equals +3. That's going to give me, back into the original equation here, 3 plus 1 times 3 minus 3. Is that greater than 0? Well, we just found out the zeros, the intercept points are the zeros, right? So you're going to get another 0 here times 4, okay, which is greater than it. So you get 0 is greater than 0 again, and that's going to be what? False. So you're finding out that these intercepts are just zeros, which give you, now if this inequality was equal to, greater than and equal to, then it would be satisfied, and it would be, the solution would live there. But in this case, the solution does not live at +3. So we putting the hollow circle here is very good, because that means the solution does not live at 3 and does not live at -1. So now I'm going to probe the inside here, and now when you probe in between these two critical values, the solution will either live everywhere in there, if one of the points works or not. Okay, let's see what we get. And then typically, if the solution lives between these, it will not live on the outside of these. So it's either or in this case. So it either lives on the outside or on the inside. So let's see what we mean by that. All right. Let x equal 0, right? That's the simplest one I can do right here. In which case, putting it into this function, I would get 0 plus 1 times 0 minus 3 is greater than 0. So what do I get? I get 1 times -3 is greater than 0. I get -3 is greater than 0. Is that true? No, that's false. So we don't have a solution in here. So we leave that empty. All right, let's test one of the spots outside here. Let's test let x equal -2. All right, let's give that a shot. Okay, -2 plus 1, -2 minus 3. Is that greater than 0? Well, this will be -1, right? And then you have -5. So it's 5. Is that greater than? Yes, this is greater than 0. So the solution lives over in the on this side. And by the way, it's going to keep going over that way. So I'm going to fill it in with a bold line and a big arrow. Okay, so there you go. We have a solution over here, no solution here. Now let's test 4. Let's let x equal 4, all right? Let x equal 4 plus 4. Back into here. 4 plus 1. And I have 4 minus 3. Is that greater than 1? Well, I'm getting 5 times 1 is greater than 0. So I have 5 is greater than 0. That's a true statement. So the solution lives over on this side as well. Okay, you've got the solution here in terms of the value, the single variable, okay? Now, what would this solution look like in interval notation? All right, when you're going out to -infinity or +infinity, you're gonna go like this. It doesn't include the end point, because there is no end point at infinity. It keeps going. So you put a half circle here or what have you, and then you put the -infinity there. Okay, and then what happens? Well, you're going to go from there over to -1, but you don't include -1. So you would put a comma here, an interval notation, okay, and then you would put -1, and it doesn't include -1, so you put that kind of a half circle here. If it included the point, you would put a bracket, okay? And it's not, but it doesn't include that point, so you put a half circle. And then you would do the same here. It would be 3, comma, plus infinity, half circle, and there's your interval notation, okay? So, and now this would be in union with this. So you would put a U. Okay, so it would be interval notation would be negative infinity, comma, negative 1 in union with 3 plus 8. Plus infinity. Okay, in union. So there's your solution. The set of x is that. Okay, the set of x. Okay, now what do we do with the two variable situation? Well, we're back to the two variable situation. We have x squared minus 2x minus 3 is greater than y. All right, what's that going to become like? Well, we don't have to redo the entire thing. We know what the factored form was. We got here x plus 1 and x minus 3, okay, is greater than y. And then we found out we had we had x intercepts at plus 3, 1, 2, 3, and negative 1. Okay, so here we had something going on here, and we had something going on here. We're going to draw a circle because it may not include it. Okay, so typically when you see greater than or less than, you're going to draw dotted lines for your graph, okay? Whatever the graph is. If you had a greater than and equal to, you would draw a solid line, okay? You're not drawing or even an equal to, you would draw a solid line. You're not drawing solid lines, you're drawing dotted lines in this case, okay? Because the solution will not live on the line if you have greater than or less than, okay? You're going to draw this, a dotted line, okay? The solution does live on the line for greater than or equal to, or less than or equal to, okay? So therefore you will draw a solid line for these. All right, now just so from your algebra you realize that there's a positive number in front of here, so therefore the graph is going to go up, all right, and not down. So if it was a negative value in front of the x squared, it would go down, but we don't have that. It's going to go up, and we have the x-intercepts, so that's actually telling us that we have the graph is going to cross over. So there aren't, we didn't get imaginary numbers here where then we get no graph crossing. Okay, so now we're going to find out whereabouts this graph will cross other areas here. And one of the ways we do that is we would say, well, where does when x is 0, what's y? Okay, what's y value? Okay, so we wanted to find out where that would be. So I would set it equal. So I would just say x plus 1, x minus 3 equals y, but let x equals 0, and that will lead me the y-intercept. Okay, so that will lead me to the y-intercept. So I get, if I do that, I get 0 plus 1, 0 minus 3 equals y-intercept. And now I have 1 times negative 3 equals y-intercept. So I get negative 3 equals my y-intercept. So I come down here, 1, 2, 3, and there it is. All right, I am going to draw a circle around that. Why? Because, like I told you, when you have greater than or less than, the solution does not live on the line. It lives off the line, on either side of the line, but not on the line. Okay, so there you go. I got this thing. Now, you can find out its vertex, okay, by the vertex, okay, point is found by letting what? You say x vertex equals minus b over 2a. okay? That's your old formula, okay? That's your go-to formula for finding the x vertex point. And now that would be, well, look in the equation. What's minus b? So minus a minus 2 all over 2 times 1, because a is positive 1, okay? So there's minus a minus 2 times 2 times positive 1. So I get 2 over 2, which is 1. So the vertex, the x vertex, is actually at 1. All right, so somewhere down here. All right, where would that be? Well, you have to put that into the equation, and you'll get the y vertex, okay? So let's put it in. So I get 1 squared minus 2 times 1 minus 3 equals y vertex, okay? So I get 1 minus 2 minus 3 equals y vertex, and then I get 1 minus 5 equals y vertex, and so I get 4 equals y vertex. So there you go. There's your y vertex. So it's one more down, and there it is. All right, so I'm going to put a circle around that guy. All right, so this is what we got here. We know it goes up, so we can draw our line. It's dotted. Okay, it goes up like this, and we can put our arrows. It's a dotted line going up, up, up on both sides. All right, and there's our x vertex 1, negative 4. All right, there's our vertex. All right, now the question is really simple. Which side of the line does the solution live? Well, I bring you back to this, and you see this is matching up very well. The solution lives on the outside of these points, so that would be out here. Well, let's see how it works out. I would do a test point, and I call it a test point. Okay, test point. Make the simplest one if you got 0, 0 somewhere. So test point 0, 0. And if it's true, if you get a true statement, then the solution lives on the inside of this. Okay, everywhere inside of the two variable area. But now, if the solution lives out, then if it doesn't live inside, then it must live outside, and then the solution's outside. Okay, so we're going to test both real quickly. All right, 0, 0. Here we go. Into x squared minus 2x minus 3 is greater than y. All right, so I get 0 squared minus 2 times 0 minus 3. Is that greater than 0? I substituted these points in this value into the equation. So I just get negative 3 is greater than 0. Is that true? No, it's false. So the solution does not live in here. So where does the solution live? The solution lives everywhere outside of here, but doesn't include the line. Does not include the line. So kind of realize that you're off this line, but the solution lives everywhere outside here, all the way out to infinity, okay? So here you go. And now just to test a point, we could test one at positive 4. Okay, you'll see. What happens at positive 4? Okay, at this point, do another test point. Okay, the test point is 4, 0. Okay, what's going on over there? Okay, so you get 4 squared minus 2 times 4 minus 3 must be greater than 0, correct? Putting it into the original equation. Okay, now what do you get? Well, I get 16 minus 8 minus 3 is greater than 0. So that's 16 minus 11 is greater than 0. And by the way, 5 is greater than 0, so it's true. It's true. So the solution is out there. And so there you go. We resolved this. So what would you say? Well, x, the solution is x, right? Such that x can what? X is greater than what? Greater than plus 3, but x is what? Less than minus 1. Okay, so there's your domain, all right, for this equation here. And there you go. Your range, all right, would be your range here would be all reals, because you're going to be below this guy over here and you're going to be up here, so your range will be all real numbers. All right, so that's that one. But your domain has to be in this in these regions. So if you put the two together, you want to make a compound inequality of this thing, you put the x in the middle, you put the lower number on the left, you put the higher number on the right. Remember which way it's pointing to, right? So the point would go towards there, and then this one would go pointing towards the x, so you would, and both of them would go in the same uniform direction. Okay, it's either they're pointing to the right or pointing to the left, but then that would be the compound version of putting that together. Well, that solves this one. Struggled to get through, but now you see a little example of how inequalities in a quadratic work out in single variable and double variable.